try to keep the time.
Ah, okay. Okay, all right. Okay, no problem. So maybe I will say some words regarding my background. So I'm a professor of informatics at the National Engineering School of Tarbes in France. It's part of University of Toulouse. So I have a background in computer science. I started with business informatics, then I did computer science masters, then a PhD on automation and manufacturing systems, and then an MBA. My story with interoperability started when I was undergraduate, and we had lecture on electronic commerce. And that was the first time that I hear this word, and I was interested. What is this? And since that, I'm working on. And I remember that's an amazing story when I was finishing my undergraduate to have my license, the bachelor. In French is licence. So for my bachelor, I had discussion with my professor that I would like to continue on interoperability. And on this time, it was the hype of web services and service-oriented architectures, and it was really a great solution at this time for interoperability. So he told me something, say, yeah, interoperability is done. It has been now, it's resolved. That's amazing that 15 years later, we are still discussing this. But that's also amazing that we are talking about other levels of interoperability. So why we talk about interoperability, let's give some background regarding this. And it's also my introduction to the progress of OntoCommons. In a report of the World Economic Forum, sorry.
I'm sharing from mine, and okay. You can use the pointer.
Okay, that's perfect. Yes, so if it works, I'm not sure.
Okay.
No, still doesn't work. Okay, I will send the next slide. Maybe it's easier. Yeah, so today I will provide some hints regarding the progress of OntoCommons and the context of OntoCommons. And let's start with some key figures. Let's say in a recent report of the World Economic Forum called Share to Gain, almost $100 billion is the estimation regarding the gain through manufacturing, processing, optimization through data sharing. So the report is encouraging companies to see their data as an asset and to make actions to share it and to monetize it. And let's say every manufacturer has this opportunity to start unlocking the value through data and value generation from data sharing. Let's say that. Also, regarding to that, there is some barriers. Next slide, please. Some barriers that we identified regarding this data value generation through sharing. Let's say that 70% of production generated data are not used. And there is a lot of barriers that lock this data sharing. There is two categories of barriers. Ones are from managerial point of view in the large sense, let's say that, regarding the ignorance, the lack of trust, the lack of strategy and vision, the lack of means. I mean, as training, IT expert, and all of this stuff for companies and especially SMEs. And there is a resistance to change regarding the acceptance of sharing. How I can trust a third party that I share with them my data, that they will respect the agreement of use. So this is a big issue. And from technical point of view, there is 5 categories of barriers: the data silos, the data accessibility, the inefficient workflows, and the data quality. So 4 barriers that can have sense in the scope of data spaces. So data spaces, from my point of view, is a way to tackle those problems. Next slide, please. So from the, let's say, the European Commission point of view and the common European data spaces can be this ecosystem that address those barriers by providing, let's say, solutions to deal with multidimensional data, heterogeneous data, and to provide trusted access, trusted tracking of data use, and all of this aspects related to data sharing. And data spaces is, let's say, the basis to reach this single data market or marketplace. Another point that we need to highlight, that when we have data spaces, we need to document data. We have to know who is the owner, what is the context of this data, but most of the time, the data documentation is based on some metadata. From our perspective, it's not enough, because data documentation should allow to understand data. And let me say that sharing is not enough. Sharing without understanding, without having the capabilities to exploit and well exploit data, is not enough. So that's why we talk about interoperability. Interoperability is to share something and to be able to understand and exploit it. And this makes sense for the data space, and also makes sense for the existence of ontology. That we believe that it's a key enabler for the democratization of data sharing and the democratization of understanding of data. But before that, what is ontology? Next slide, please. So I will avoid to use regular definitions. From our perspective, ontology is a bridge between the human view of reality and the machine understanding of this reality. So ontology is not data model, but it's a model for relating data to the reality. It's come from philosophy. It's about the science of what is. And it's the same for the machine. Machine, when it deals with data, has to understand what is. So it helps, let's say, agents as humans or as software agents to have a shared view of the reality based on consensus, based on common sense, experience, and metaphysics. So it's a key enabler to interpret and understand the meaning of data, and data documentation have to be ontology-based, because we need that in order to extract value from data. So ontology helps to have interoperability, but this suffers from interoperability. That's amazing, because there is a lot of ontology, and we will see through the landscape, we identified a lot of ontologies. The same problem is there. We can't exploit different ontologies because they are not interoperable. So let's say also that ontologies in semantic web or in data engineering and also in philosophy have overlap in their scope and in their purpose, but the focus is different. In computer science, in semantic web, we are interested on the format of the data, format of the vocabularies that we are using, and how to access, how to manipulate it. But in philosophy, the focus is usually what is. So the focus on the philosophy is more on the semantic web. That's amazing because you are talking about semantic web, but we are missing something. We are missing semantics in semantic web. Because unfortunately, it was the case for me as a computer engineering person and having this background. At the beginning, any OWL file, it was an ontology for me. Any outcome from Protégé, I craft something on Protégé, the outcome of that is an ontology. But it doesn't work like this. We know a lot of projects that it fails. We can mention OntoStep, for example. So the problem also is that the acceptance and the attraction of ontologies in industry, it's not usually the case because it's seen that it's difficult. It's very abstract. Why we are doing that? Why we are rigorous? It's okay. We develop an ontology and we use it. Just all. Why you are discussing regarding semantics, metaphysics, logics, axioms? It's so complicated for the end users, for the people from industry. They don't like to see that. What is occurrent? I don't care. People say that. All right, I can understand. But because the perspective sometimes is different. The perspective is from the data engineering practice and use, and I understand this. I have this background. But what I can say is, please let's have a balance between the semantic richness in general and the utility. And this is very important. Next slide, please. So here there is a list of, for let's say 2 decades, a lot of ontologies have been developed, even in European projects, in different initiatives, in different domains. But there is something common between most all of them. They are not fair. They are not findable. They are not interoperable. They are not reusable. And they are accessible. They are not accessible. So there is a big problem for this community, and also there is a miss regarding the use of standards. There is a miss regarding the use of standards, and we try to understand what is the problem, what is the reasons of this failure. So we try to list this in the next slide. Yeah, so let's say that there is many ontologies, but there is many initiatives, let's say in ad hoc ways. And there is a lack in terms of methodology. There is a lack of reuse strategy from the beginning. We ignore standards in the domain. There is also a problem regarding the validation of ontology in terms of quality. There is no standards regarding evaluating the quality of this ontology artifact. There is also different perspectives and paradigms of thinking. Should be conceptual, realism, 3D, 4D, all of this stuff. There is poorness in terms of training, documentation, and let's say fairness compliance is most of the time ignored. And this, all of that make the life of ontologies so short. We believe in OntoCommons that ontologies are important to reach data sharing and data interoperability and to generate value. That's why we are working in OntoCommons to answer to this failure reasons and to resolve them. So please, next slide. So in OntoCommons, we are trying to develop an ecosystem. We call it OCHES, Ontology Ecosystem, as a foundation for data documentation in order to answer the reasons that we identified. So next slide, please. So OCHES, what is? It's a combination of fully harmonized ontology artifacts from top to domain level, and associated also tools and methodologies for building and creating future ontologies. The complementarity of OCHES components provide a complete solution for data documentation in different domains, and especially in MVP. So I will not go through the details of OCHES, so we'll have a dedicated presentation for that. But what we are doing is really to build a hierarchy of ontologies, starting from the top level to the domain level. That's what I'm explaining in the next slide. So we are building a top reference ontology based on harmonizing top-level ontologies and using this to harmonize mid-level and domain-level ontologies. So for that, we are ensuring, let's say, different levels of harmonizations, like syntactic, terminology, semantic, formatting, and we are using an approach based on what we call bridge concepts. We are also adopting a pluralistic approach in OntoCommons, what means that we are using, or we believe that there is no one reality, so that's why we adopt that there is different ontologies in the same domain. It can be different visions in the same domain. So for that, we define two kinds of interoperability between ontologies. In the next slide. So there is the intra-ontology interoperability, which is interoperability by design. It means we have a branch of interoperability from the top level to the domain level. So all those ontologies are interoperable by design because they are following the same top-level ontologies, the same principles. And then we have this cross-ontology interoperability. It means if we have ontologies from different top-level branches in the same domain, we use this approach of bridge concept in order to align them and to harmonize them. And this is the heart of the system, because we try with this harmonization is to democratize ontology. Next slide, please. So in our approach, we are basing our development on standards. That's why we link with main SDOs, initiatives, associations, projects, and we are working in collaboration in order to not do the same reasons of fails. We are trying to work in community because we want to reach commons. So this the line of OntoCommons project is to build commons with the community, and for that we are not building the OCHES, but also we are building a roadmap. Please, next slide. Yeah, so we are, in addition to OCHES, main outcome of OntoCommons is the OntoCommons roadmap that we are building, and there is the first version is already online that you can find on the project website. And we try to, on the different purposes of the project, is to identify the industrial needs, the gaps, and the recommendations. And to conclude with that, also we have a session on the third day regarding the OntoCommons roadmap to have this opportunity to discuss more and have feedback on this first version and build together the second version, the final version of the roadmap. So to conclude, in the next slide, slide please. Yeah, so how OntoCommons endorsed the European Single Data Market Direction. So we highlighted the importance of openness. So we need to have interoperable meta models to ensure fair, to standardize data documentation for both intra and cross-domain technology and know-how transfer. We blend and evolve the relevant European communities, so as a CSC project, and also, let's say, build the roadmap with the stakeholders. and refine underground the vision for a computing continuum. And by that, we are developing a repository for sharing semantically annotated fair results of academic and industry research, and we are pushing to do that, and also to, let's say, to collect and to provide the best practices produced across the overall EMI 2030 ecosystem. And let's say standardization is very important. And one of the, let's say, conclusions that we had with the community, let's say, in the different workshops is we need to standardize ontology and we need to ontologize standards. This is very important. And for that, we started to make progress. I'm happy to share this information with all of you that OntoCommons is signing now in, I mean, it's in signatures phase with PCA, a MOU regarding the adoption of OCHA's ontology ecosystem for the development of the part 14 of ISO 15926. So I think that's a great achievement and it's a great share with the community. It's allow us to validate OCHAs and also to contribute in standardization through OntoCommons. So my last sentence is to say that we are contributing to data space semantization, to allow cross-domain data spaces interoperability, and then allow data marketplaces. That's all. Thank you.
So there is hope for OntoCommons for ontologies to be practically used. So just I share you my very recent experience. So last week I was in Stuttgart in a professional works conference about smart manufacturing, and I was approached by a small company selling or developing AI solutions for industry. So the European Central Bank is among their clients and they are proud of it. And they approached me because they discovered that I'm part of IOF, Industrial Ontologies Foundry, so I informed them about OntoCommons also, and they approached me because they want to ontologize their solutions. Apparently, they discovered that the AI that developed with neural networks, etc., has problems. So industry is discovering the need to have commons in their data management and in their solutions, and this is promising. So now we are going to the third talk, so applications of ontologies in digital marketplaces, and we will have the talk about that and standard documentation principles in digital marketplaces with Amit Bhave and Dirk Helm from Fraunhofer.
Thank you very much. So, coming to the next presentation, an experiment about digital marketplace based on shared data documentation principles is a joint talk by Amit and myself. And I would like to start with a short introduction about the materials, about data spaces, about marketplaces or digital marketplaces in principle, that we all start from the same perspective. And what I would like to introduce is first in the industrial needs perspective and the perspective from an engineer. And as an engineer, we are quite often in the situation that you must make a material design. That is the left box. So we talk about nowadays about virtual material design. We talk about material discovery by using simulation engines. After we design the material, we have the challenge to process the materials, and we need a process design. Also this we do nowadays, or would like to do in the computer by doing a virtual design of the processes. And in this field, we must analyze, evaluate, and optimize the process, a single process or a whole process chain. So it's a very complex simulation challenge. After we have a semi-finished product, we must make a component design. We talk about component performance, about the crash performance, for example, and we have the lifetime. And the lifetime is also the keyword to talk about sustainability. At the end, we need a system, a platform which supports the engineers to reach a more sustainable design. And to make sustainability possible, you need a lot of data, you need a lot of virtual tools, simulation engines to enable exactly such a sustainable design. If you go to the user perspective and ask the users, we can ask different categories of users, like, for example, an engineer in the R&D field, for example, of an SME, and maybe say do additive manufacturing and would like to simulate the process of an additive manufacturing route. That is quite complex from simulation perspective, and SME typically has not the capabilities to do such kind of simulation, so they are looking for an expert to support exactly this process. A researcher, for example, has maybe developed a nice model, but has no data to calibrate the model. They would like to come in contact with providers for data. And of course, also such a researcher is be interested to exploit their material modeling techniques to a wider community and use something like a digital marketplace. Software vendors, also here, big software companies have no problems to build a big platform. SMEs have much more challenges to build a platform. So they are interested to go on a platform and use their monolithic software solution in a way together with other software solutions to enable, for example, multi-scale modeling over multiple scales. And as a consultant, say no, that is a successful industrial materials modeling needs more and more the assembling of knowledge, software, and data from a wide range of fields. So all these data and tools must be available. And that is a principal idea if you talk about marketplaces or digital platforms. So there's maybe one entity who provides an infrastructure that is more or less no big information inside, and we all make it to a marketplace by either using this platform or providing data and tools on such kind of a platform. If we maybe asked ourselves what we would like to have on such kind of a platform, we would like to have access to data like material data, modeling data, validation and benchmark data, catalogs and services. What's, for example, a big output from the ESC activities, access to simulation data, and of course, not only access, we would also put our data to the system and provide the data to others. If we look to the softwares, then we would like to have access to the software, but not only to a catalog of software, we would really use the software over such kind of a platform and carry out our simulations, for example, or run a program about such kind of a marketplace. And this could be material modeling tools, could be simulation tools for process simulation. We would like to be able to configure our workflows to combine different kind of simulation tools, for example. A library for solved problems would be useful. HPC services for complex multi-scale simulation is also needed. Then we would like to have access to different services, which is maybe related to something like you would like to find a translator who support you to solve your problem. Also here an SME is maybe not be able to solve the problem alone, so he need an expert, or they need an expert in the way of a translation service. So we need something like service providers, educational capabilities and discussion capabilities, and of course also billing services. And the last row of some needs is something like artificial intelligence. So more and more on the data we will use artificial intelligence to get an added value. So we need some possibilities, a framework for the AI integration in such kind of a platform. And on the platform itself, we would like to explore our data, evaluate the data, and of course, we would generate new knowledge via such kind of a data, and also with support of the artificial intelligence. And at the end, trust on the services is quite important. Trust on the data. Topics like data sovereignty, data safety are very important here. If you collect all these things together, a little bit delay if I press the button, and collect these feedback analysis, of course, The left box is more related to materials modeling issues because the marketplace I will present later is related to this, but data are also very important here. We have on the abscissa the terms create. We would like to be able to create data. We would like to be able to explore data, to interact with data, with the community, and to execute something. And on the ordinate, we have the broker, the provider, and capabilities to utilize all these techniques. If you look now to the market, there are already marketplaces on the market, like Science Exchange and QuestPair, which are more in the lower left corner of this diagram. There are platforms like IDEX Lab, who provide already data and enable interaction with the community. And there are platforms like Material Square, who are focusing on the interaction and the execution of codes. And what is needed from our perspective, from the marketplace, is something like a holistic approach where you have access to all these things, and there's something like a one-stop shop for material modeling, for the material data, and other kind of data. And the keyword data is the right keyword to hand over to Amit for the DOME 4.0 perspective.
Thank you, Dirk. Good morning, everyone, online and in person. I think, the data is the right point at which this handover happens. I completely agree. Just to put the expectations into in the right place. When we talk about data, there was a very interesting point that Michaela started with this morning about sort of encouraging and enabling creativity within industry commons, but also letting actors, letting agents act in their heterogeneous way, because that's how you really enable creativity on one hand, and then to take a point from Hedi's presentation about still having that consistency, still having that consensual sort of acceptance of what you're doing, at the same time not breaking things and just creating something randomly that cannot be scaled. So there has to be a balance between these two forces. I think that's where we are in DOME, because we bring a practitioner's perspective on data marketplaces, and we go beyond that in terms of going from a marketplace to an ecosystem. And as soon as you get into that ecosystem space, the heterogeneity plays a vital role. What I mean by that is, first of all, just to introduce, DOME stands for Digital Open Marketplace Ecosystem. So ecosystem is the key word here. So we don't want to just develop yet another marketplace. We want to be able to work with different marketplaces, open simulation platforms, open translation environments, like OntoTrans, for example, different knowledge bases and different databases. So DOME is a multi-sided ecosystem where you have, as a participant to the ecosystem, you have the data consumer and the data owner. You have the data provider and the data owner. And critically, you have the digital and data service providers as part of the marketplace. So beyond that connection with the data prosumer, what we have ambitiously started is developing the semantically enriched core for the DOME platform, and over the next 2 days, we'll share some of the updates from the project, and also the 9 industrial B2B showcases, and some of my colleagues, for example, Evgeny is here, so please feel free to interact with regards to the status of the industrial B2B showcases. And most importantly, as Hedi highlighted in his talk, how do we do this with the fair monitoring context, not just with the ontologies as an enabler, but also the data, because the data itself has different formats, is heterogeneous as well. So the 9 B2B showcases we are targeting, again, we'll go into the details of these in the session 2. These cover a lot of areas, mostly to do with materials, manufacturing, environment, chemistry, etc. The point in DOME is, it's the reason I call it ambitious is because we are progressing well on these 9 showcases, but at the same time, and this is the sustainability aspect, so Gerhard is here as well from GCL, where we are talking about how to map and how to connect between the 2 showcases so that we can then really scale this up and expand the overall appeal of DOME. So I'll also present some of the examples in session 2 on that. So it's not just delivering these 9 showcases, but also the maps between and the connections between the showcases for the overall public good. DOME is a fair challenge in the sense that we want to, as I said, connect with OSPs, marketplaces, databases, knowledge bases. And what that means is, if I take the analogy of as I had to travel from UK to Germany, the first thing was the adapter, right? The power socket for charging. And each of these simulation platforms or the assets, information assets or knowledge bases have their own way of connecting. So in short, you need to develop tons of connectors. As a cartoon, to take single point away from this is what we want to develop is that sort of a universal adapter for hardware interoperability. It exists. So this image is taken actually from the one that I have on my desk currently. So that's what we would like to bring, a semantically interoperable ecosystem that connects seamlessly with different heterogeneous knowledge bases. Which has a lot of parallels, of course, with the concept of data spaces. Sorry, there's a bit of a lag. So just to harp on the concept of connectors. Connectors is a word that's generally thrown in when it comes to marketplaces. Just to give it some context, what we mean by connectors here are both syntactic and semantic. And there are lots of questions that we address while working and developing these connectors. Currently on the DOME platform, you can see some of the connectors that are already established. For example, the Market 4.0 with the IDSA connector, the International Data Space Association's connector. Then the Nomad Materials Project, AIDA Lab, etc., PubChem and Chemio as well. When we develop these connectors, the typical questions that go in is the type of data we are aiming to get or receive, the quantity and the size of the data, also the streaming of the data. Where is this data exactly stored? Are we going to move the data physically from one location to the other? Or is it just the semantic part of that data that's been moved? Whether there are any tokens or account registration, access rights. And finally, how are we planning to present the data that has been returned from the server, just as a visualization, as a dashboard, or as a JSON object, which can then be moved around or mapped. So with that lot of thought, of course, on one hand, we have been developing the connectors. On the second, as this session 1 presentation is just an overview, I won't go into the details of this. But we really thought that we should have a minimum viable prototype out there. It's of course not perfect with full-on features. I admit that, but the partners have done a great job with trying to put something out there and then to continuously improve it in that sort of agile software fashion. So it's a very simplistic platform to start with, or a demo to start with. Where you can have these data sources accessed and you can search and query them. So to end this joint presentation, just to summarize at the end, so we have released a MVP, a minimum viable prototype. This is with some initial features, and it forms a foundation for further development. Then in collaboration with OntoCommons, and you will hear about this in session 3, we are bridging the gap between using the W3C light ontologies with a highly expressive framework. And this is that sort of semantic enrichment of RDF and vocabulary work I think Emmanuel is presenting this in session 3. The ecosystem ontology led by Sylvia, again, who is here for more questions. Feel free to chat. Ecosystem ontology is based on the project scope and the reuse aspects in collaboration with OntoCommons. The aim is to connect with as many marketplaces and knowledge bases as we can while delivering the 9 showcases as a minimum. We've started doing this with the likes of Market 4.0 and common databases like PubChem and Chemio. And currently the 9 B2B showcases are progressing in an offline mode. What I mean by offline is they are not yet part of the DOME platform or the DOME ecosystem, but these are already cross-sectoral showcases which need to be progressed further. And I would like to cover the advantages or the pros and cons of this approach in the session 2. So that sort of brings to an end the joint delivery, and back to Dimitri. Thank you.
So now Yann will tell us all the secrets of FAIR and their principles to make FAIR ontologies. Thank you, Yann.
So good morning, everyone. My name is Yann Lefranc. I'm the CEO of eScience Data Factory. I'm also the scientific director. So eScience Data Factory is a company I created almost 10 years ago to actually start working on the field of data management for science. So my training is not IT at all. I'm a biologist, and I worked in neuroscience and computational neuroscience. So I quickly faced, in fact, the problem of, well, the need to handle the data from others, actually even managing the own data that I was generating at the bench. So that led me, to start working on these issues. And now we are deeply involved in several projects in the realm of EOSC and semantic interoperability. And so today I have the hard task to actually give a presentation and an introduction on the FAIR principles. Hard because it's a large topic. Second, tomorrow we have a full day session on FAIR principles. So I'm trying to give you a very short overview right now as a teaser for tomorrow. Next, please. So what are the FAIR principles? So the FAIR principles are coming from a paper that was published in 2016. And actually, it came up even further from a discussion between scientists, data managers from different scientific communities, including neuroscience, also with the publisher that joined into a group that was called Force 11. And out of that group, a lot of more people added up, and then they published the FAIR Guiding Principles for Scientific Data Management and Stewardship. FAIR is a nice acronym. It means findable, accessible, interpretable, and reusable. Next, please. So the interesting things about FAIR is that it's been picked up very quickly. So it's been adopted almost as soon as the publication came out by different organizations, including the European Commission, the G20, G8 scientific minister, because it's one of the leading principles for helping with open science, right? So a lot of momentum has been gained on FAIR principles, and I'm pretty sure you all heard at least once in the past 2 weeks about FAIR principles. You're going too fast. Can you go back? Go back one. Thanks. So, yeah, next. Next again. So, yeah. So slow. Okay. So, thank you. Yeah, I will. So the main idea of the FAIR principles is to provide a solution to better organize and arrange the data that we are sharing to enable data-driven science. And the main idea is that data should be transformed into a machine actionable unit of information that you can share with others, that you can make it easily findable. So we heard, for instance, Dimitris saying about AI. AI requires a lot of data for training. And so if the data was actually fair, it would be much easier to actually find and create the training data sets that you require for your AI approach. The same goes for the industry commons. Basically, this would make it a valuable shared unit of information that could be actually commercialized, because that data is then of quality. At least you know that it's well documented. So here are the FAIR principles, right? Organized along the 4 axes: findability, accessibility, interoperability, and reusability. So you have in total 15 FAIR principles. And I will not necessarily go into the details, otherwise it will be too long. But the interesting part is if you start looking at them individually and then look at the globality, that something goes wrong with that slide. Basically, most of the principles are focused on metadata, right? So the key for FAIR and the key for machine actionability is the documentation of the data. That's the most important part of the thing. A data that you just provide no information about is just useless, right? I can tell you 42, you will never have a clue about what I'm meaning. It could be the answer to the question of the universe, right? It could be anything. So now, if we start thinking in terms of practice, implementing the FAIR principles, is it a technical challenge? If we start looking at the individual principles and we start thinking in terms of technically what it represents, was not that complicated. You need a globally unique, persistent, and resolvable ended identifier, right? That will identify both your metadata and your data. Then everything is about metadata at different levels. That's provenance metadata, that's vocabulary and ontologies to actually convey the meaning of the metadata, using domain-specific metadata standards when they exist, and to make that metadata persistent, right? And then you have 2 other aspects that are linked to the FAIR principles. One, they need to be published through a free, open, and universal access protocol, right? So basically an open API, and then they should have licenses. Now, is FAIR really just a technical challenge? In fact, not at all. The hardest part when you start implementing FAIR principles is that every community in science, at least, but certainly also in industry, has its own view on what is fair and what is not fair, and especially around the metadata. And here, I'm just putting here just some of simple questions that need to be addressed, not by machines, but by human first, right? Regarding the persistent identifier, who should guarantee the persistency of the identifiers, right? Which organization is going to do that? And for how long, right? What does it mean to be persistent? Is it 10 years, 20 years, forever? This needs to be done. It's the same thing. The FAIR principles on metadata, they say you need to provide rich metadata. Rich metadata, what does it mean? Right? It means everything. It means from one metadata field to an infinity of metadata fields. So where do we start fixing that threshold, right? Which metadata schema and element should be used? We don't necessarily know, and this is on case-by-case basis, community-by-community basis. The same goes for provenance. Provenance is extremely important, but to which degree of granularity do you want to go? I mean, you need to actually set also a threshold there. The same goes for the usage of vocabulary and ontologies. They must be fair, and so on and so forth. So basically, there are tons of aspects that are definitively not technical barriers, but social barriers that needs to be addressed for the implementation of the FAIR principles. And I will give you a few examples. Oh, this is not the last presentation. Sorry, it's okay. So there's one example that comes to my mind. I changed the slide at the end, so that's okay, don't worry. So one of the examples I wanted to talk is the principle I2 says that metadata should use fair ontologies and vocabularies, right? So one of the issues, how do you define what is a fair ontology or vocabulary. Hedi said rightfully that semantic web is it's a nice ecosystem, but then it's not really well organized. There are not a lot of good practices on how you develop an ontology. Is your ontology just an OWL file? Actually, they don't even agree on the concept of an ontology, right? There are papers that say that an ontology is not SCOS, right, for instance. Well, some others say the opposite. So that's a reason why in one of the European projects that's called Fair is Fair, we started discussing about semantic artifact, which is a machine actionable representation of semantics, basically, to avoid any of this conflict. So basically, in the semantic web realm and the ontology realm, there's no real clear guidelines and good practices, shared good practices to actually develop the ontologies. And so one of the issues we had to face is in order to come up with some recommendation in the Fair is Fair project, we had to work hand in hand with many communities to try to collect a lot of their feedback to see if we could come up with some common guidelines. Another, this is an organization, GoFair, you may have heard about them. Tomorrow, Baron Mons, the scientific director of the GoFair Foundation, is going to give the keynote to introduce the FAIR principles. Basically, in GoFair, that's an organization that actually tried to bring together the different communities into what was called an implementation network, and started to work with the communities to define some practical implementations or possibilities to implement the FAIR principles. So for instance, there is the metadata for machine workshop, there is the FAIR implementation profile, and the FAIR data points that are going to be presented tomorrow. Just to give you an idea, the idea of the FAIR implementation profile is actually to cope with that social aspect, which is, well, how can I collect the diversity of approach to FAIR? If I need to provide a common way of doing things, I need to understand the diversity of approaches. So basically, let's have a questionnaire that we could run through the different communities and evaluate the different resources they're using to make their data fair. Well, FAIR principles are at the heart of EOSC, and I'm going to quickly on that, because EOSC should involve the federation of existing research data infrastructure. So in a sense, that's a science data space. And basically, the idea is that it should help the realization of a web of FAIR data and related services. And EOSC is not, EOSC is just an association. There are actually tons of projects that have been funded recently that actually are contributing to answering these questions. How do we make data fair? How do we construct a web of fair data and services? And I will stop here, I think. Yes, so I will just invite you to stay here for another day. Tomorrow we have a full day session on FAIR principles where we'll have an extended intro on the FAIR principle. Then we'll have examples of implementation by industry. And then we'll have a presentation of the work we have been doing in OntoCommons on FAIR semantics and evaluation of FAIR ontologies. And then you will also see and have a glance of all the resources that could be used if you want to implement FAIR principles in your case. Those who are developed within the realm of EOSC in the different projects, and also all the resources that are provided by GoFair. And that's it for me. Thank you.
So now, we will go to see about materials and material commons. So as we said at the beginning, so nothing happens without materials, even services to be delivered, they need something material to be present or available to deliver good services. So Gerhard Goldbeck will talk to us about materials and methodologies, material commons.
Thank you. Thank you, Dimitris. Thanks for the opportunity to speak here today about the Advanced Materials Initiative and Materials Commons. So just waiting a sec for the presentation to come up. Hopefully I can also operate it with this thing. I will just try that. I will just try and forward the slide. Yeah, that works. Okay. So yeah, I'm here today in two roles, as it says also on this slide. I'm the managing director of Goldbeck Consulting, based in Cambridge, and we're a partner in the OntoCommons project, but also other related projects, in particular OntoTrans, that has also contributed to this work. And I'm also, in a part-time capacity, the executive secretary of the European Materials Modelling Council, which is an association based in Belgium. So today, the context is materials commons here, and this is kind of the vision that has been developed in workshops also with Commission and with the EMMC, that shows that how we can really make better use of materials for the requirements and the needs of society. You know, the key part of materials is that they're part of any good, and also, you know, part of the problem and part of the solution of what we are driving for. And we need to develop a more safe and sustainable and more circular way of doing things. And so we can gain information from many different sources, from modeling and simulation, characterization. We have a lot of data, and we need to make them work better, and that can be done by what is shown at the bottom here, a foundation based on better sharing of data. And this is the topic that has been, of course, already discussed by the speakers before, that ontologies here also play a key role to make that happen. And another way of that we are looking at it is this cycle, and this should be basically a virtuous circle, that there are many techniques in materials investigations by which we generate data, but generating the data is not enough. We want to then exploit them and use them. But how can we do that? We need to underpin that with a better documentation, better management of the data. So if we don't see that as someone else's problem, but engage in this cycle of activities throughout and in all activities, then we have a chance of implementing that vision. You know, from the perspective of the EMMC, there are many issues and problems in the current situation. In particular, there are scattered materials data and knowledge resources, data of various levels of quality in a wide range of repositories, in publications, unstructured data. Many lack context and meaning that make them reusable by others, as we're discussing here. So that leads to a more single-time use and not much reuse of data. The methods by which we generate data in themselves are often not interoperable, not really digitalized. They're kind of electronic, yeah, in Excel and so on, but not digitalized. There is no standard regarding data and metadata, and each project has its own way of developing certain annotations and schema and so on. So this is what we want to then overcome, and we've drafted also from the EMMC side a roadmap which looks at the building better digitalization and data interoperability foundations in the field of materials. In particular, the aspect of fairness that Yann has talked about so very well is really key here. And I really like also the point you made, Yann, about the socio-economic and societal impacts. You know, we can ask everyone in projects to do a data management plan, but that doesn't lead to data management, right? And I think that has largely, in my view, failed to actually achieve the goals of fairness. We need to develop digital strategies that combine also the advances that we have in AI with semantics, and really develop then the capabilities and capacities to make better use of advances in modeling and simulation and characterization, but also, again, the human dimension, educate people on how they can use the tools, how they can be involved, and there will be new roles such as the knowledge management translator that we are discussing also in the OntoCommons project, that can really again fulfill that human side of things, and really bridging the gap between the knowledge that is common maybe in the digital expertise and that of material scientists, for example. That all of these aspects need to then be integrated into an ecosystem of materials commons, which is more than just about the data, but really about the governance and the implementation, the curation and the trust. So all of this together then leads to, I'll try and go back a slide, a more outcome-driven, accelerated and improved materials design, development and use. So the pyramid here shows that we want to reach really better decision making. Yeah. But better decision making requires insights, requires sense making. And sense making is really where the ontologies then come in, that need to be linked to all of the data and their management, that at the bottom of this pyramid are generated by a range of different methods. That will require really a collective effort of diverse communities of material science, data science, and semantic technology expertise and innovations. So a broad spectrum of disciplines involved. Now, I want to talk in this context about an initiative called the Advanced Materials 2030 initiative that started really with a manifesto, the so-called Manifesto 2030, that was presented to Commissioner Gabriel, I think in February last year, signed by a number of organizations, including Fraunhofer and that is hosting us here today, and many others from industry as well, that underpinned and underlined, pointed out the key role of materials in safety and sustainability and addressing many of the problems in society today. And from that, an initiative has been launched, which includes a number of technology platforms, and that is now working on a strategic agenda. And the ambition of this Advanced Materials 2030, or AMI 2030, or AMI 2030 initiative, is that advanced materials are a source of prosperity for the EU society, but there are many challenges, failures and gaps, including the need of developing increasingly complex advanced materials that really drive the profound aspiration for safe and sustainable society, as well as unprecedented market needs. But at the same time, we have a very fragmented landscape. I already talked in my slide earlier about the many different competencies that need to be brought together from different fields, but also we have a fragmented landscape in terms of EU national and EU resources between large and small companies and so on. So that is definitely a challenge in that, and we have EU leadership that is still in place there today, but really at risk in terms of advanced materials innovation and industrial competitiveness in strategic markets that EU has been leading in. And also, as has been experienced in the pandemic, there's a lack of resilience and sustainability in value chains that needs to be addressed. So all of these things are really at the heart of the AMI 2030 initiative as a multi-sectoral accelerator for the design, development, and uptake of sustainable advanced materials. There are a number of cross-cutting needs of markets and priorities that are addressed. I'm not going to go into these, but they're basically intersections also of materials and then also of processing and manufacturing, which is really at the heart also of the OntoCommons project. What I want to talk about today is the areas of intervention which are really aimed to address that. In particular, there is the digital technologies for materials intervention, which is one of the pillars supporting this ecosystem and its impact on a wide range of markets and innovation markets for materials. And so for these areas of interventions, then the AMI 2030 has working groups, and I'm pleased to I've been asked to share to chair the working group on materials digitalization, which has contributed to the AMI 2030 roadmap and will also then continue working on its continuation in terms of further detailing of a research agenda. And the objectives of materials digitalization is really to deliver a common digital ecosystem, meaning the working on the interoperability between all of these technologies that I already talked about earlier that can generate data, yeah, and then to capitalize on these commonalities and integration and synergies and contribute to a federated but highly harmonized and interoperable materials data infrastructure. And the outcomes are in fact expected to really impact the design, development, and the use phase, and then also reuse of materials in terms of, again, the better decision making for efficiency, reliability, safety, and sustainability, using materials really in terms of the value, a high value that they actually represent. So in a roadmap that was published at the end of last year, then AMI 2030 has a section in that roadmap on materials digitalization that is again built around these 4 areas of generating data, documenting, managing, and exploiting data, and calls for actions to improve each of these areas into a common system. And as you can see, again, terminologies, ontologies play a very, very big role in making this actually happen. So the AMI 2030 expected outputs and results focused on materials digitalization is that it calls for really game changers in terms of the development of technologies that support advanced materials development by exploiting existing and generating new data with harmonized and digitalized technologies in modeling, characterization, production, and testing technologies, semantic technologies, and AI, to support systemic collaborations, integrating all stakeholders by developing a common documentation language for data exchange and knowledge management. And this is really one of the bigger challenges here we are talking about today. How can we really develop a system whereby when we talk about metadata, when we talk about terminology, ontology, how can we make it really a common language that the whole community can feel that they can really contribute to? And it's not something that is done by some expert out there, right? So this is the big, again, a social and human resource challenge that we also face here, as well as a technical challenge. And then that will build this common toolbox of a materials data space using distributed data repositories with trusted data management access and exchange for all stakeholders. And altogether, this can build a vision that we have data spaces which are already being built in the area of manufacturing, closely connected to those in the materials development world, so that we can track materials throughout their life cycle. So that means, what does that mean in reality? If I buy something today, can I see where this material come from. Yeah, if I design something today, can I see the horizon of how it can be used? So this is basically the whole life cycle that is shown on this slide, and within that, this circle of generating data, documenting, managing, exploiting data in a virtuous cycle way that supports this integration of materials and manufacturing and doesn't leave materials as something that is somewhere done at the beginning and maybe we think about it again when we want to recycle, but it has really an eco integration throughout. For those of you interested in further discussion about the materials and digitalization area, there will be the EMMC 4th International Workshop in Vienna at the end of April, 26th to the 28th of April, where materials and digitalization as the backbone of the green transition will be the theme. So you're very much invited to that. And with that, I would like to thank everyone and also the project funding as shown here. Thank you.
This morning session with Andrea Ceglia from the European Commission to give us elements of the policy of implementation of materials and manufacturing commons. Thank you, Andrea. The floor is yours.
Thank you, Dimitris. So, first of all, let me say that I'm the last one of the session. I know you have to go to the toilet, you want a coffee. It's a very hard position in a program when you're the last one. But I have two good news. My slides are short. I mean, it's only 8 slides. And the second part is that half of them are useless now because of what the other said. So it will be quite fast. But getting serious, I think my presence adds on top of Laszlo's, shows how much it's interesting for the Commission and for us, the work you're doing. So there is a lot of interest in ontologies, in data sharing, data knowledge, and also how to make value out of it. So we want to hear from the community, from you, that you are the expert. So let me see if it works. Not really. Doesn't change. Can you change? Nobody can change then? Who has the control? Okay. You can then change for me. I will put the large frame on what we're doing. You know, the Commission has 6 priorities. 2 of them, maybe the most famous, are the Green Deal and the digital transition, the digital age. These are just the headlines, you know, what you will find on many of our communication fact sheets. What are we targeting? So we want to have a climate neutral continent by 2050 with a high number of intermediate targets, challenging. We want to have a digitalized society, and digital skills should be pervasive at all levels. So these are the big headlines. But what we want to achieve with this, we want to achieve a circular regenerative economy. Well, you can change the slides. And this is something that you have been hearing some hooks here and there. Michaela mentioned Kate Raworth, but she is also a big fan of this. Ursula von der Leyen herself, she mentioned the regenerative economy as a model for our growth. We should move away from extraction to regeneration. What does it mean? It means to enable a system that is able to reuse products, materials, energies that are done here and there, and not lose them in waste. And this requires a systemic thinking at all levels, at design level, at extraction level, actually even before. At extraction level, we should do extraction in a much more efficient way. And that's what came in the recent adopted Critical Raw Materials Act. I don't know if you heard in the news. The Commission is fostering, is launching a lot of initiatives to have a better extraction system in Europe and beyond with trade. But so starting from there, but we have to look at the design, at the manufacturing of products, at the reuse of part of these products, at the disassembling technologies, and so on, consumption and recycling and collection of waste. So next slide. But why are we talking about materials commons? Because materials are the engine of innovation. Now I have 3 examples here, but actually, you know, there are about 15% of the Nobel laureates got a Nobel for materials-related research. And these are the last 3. Well, I skipped one, actually. In 2011, there was another one. But the last 3 related to materials are graphene discovery by Game and Novozlov. The 3 Japanese researchers, Akashi, Amano, and Nakamura, for the gallium nitride blue lead, the work that led to the discovery of the blue lead, which actually started much earlier in the 60s. And okay, you know how the Nobel Prizes work, huh? And then the Nobel Prize in Chemistry for the discovery of lithium batteries, with all the evolution from the good enough use of lithium metal, which was explosive and made them think, okay, this is not viable, up to the optimization with the Whittingham and Yoshino. Next slide. But so we know the materials are important. So important that they even gave names to the ages of history of mankind: Gold Age, Bronze Age, Iron Age, Plastic Age today. And we have a very strong position in Europe, but we are losing this position, not because we are not good at developing new ideas and new materials, but also because the global competition is much tougher now. China is growing very fast. Japan has always been very strong in this field. So I think this is also the rationale behind the stakeholder initiative that Gerhard already presented, so I can skip basically ENIT 2030. But the vision maybe is very good to repeat it. We want to have a very strong European ecosystem that builds bridges between different parts of the ecosystem, because the materials ecosystem is very fragmented, it's very wide. Imagine how many materials are everywhere on anything. So it is really a huge effort. Next slide. And what can we do with digitalization? And now ChatGPT, we have GPT-4, a lot of hype in the news. But indeed, AI has the power of harnessing new knowledge, create new knowledge out of data. AI for Science is an initiative, actually also the decommissioning is now in the GRTD, Research and Innovation, we are working on. Because we think and we believe that if well used, AI is a powerful tool. And you know the discovery of DeepMind with AlphaFold for the discovery of the prediction of protein structures. Very accurate. They're winning all the competitions in the field now. I have a very dear friend who works in protein prediction, and they're the best in AlphaFold. And governments also started realizing this. We know the Materials Genome Initiative in US, launched in 2011. In Germany, where we are now, the Material Digital Initiative. So we think that in Europe we need a better structured, federated governance for data management. Next slide. I don't remember what is next slide. Can you? Okay. Oh, well, that's a very important one. Many of you will recognize the projects we work on. This is a little bit of history, recent history of EU-funded projects in the field of ontologies, marketplace, data harnessing, which starts with the, in the slide that I prepared, I start with the EMMC, but maybe I could have started a bit earlier. And with the latest projects that have been funded in 2022, calls of Horizon Europe. We have a very large community. I have a question for you. How do you work together? How do you build on each other's results? I heard today by Gerhard that data management plan probably are not a good way of having data management in projects. Maybe you're right. Maybe we should rethink that. Well, all these projects I know that you're working already with them. They should be working with the Digital Europe program funded Data Space 4.0, the European Science Cloud, we heard Yann speaking about it, the national initiatives such as Gaia-X. Next slide. There is a little bit of lag. Well, this slide now is not very much of use because you know the history, Michele already told you. I was more coming from a positive perspective, but now I know that Eleanor Ostrom told us that commons were not so good. And it's true, probably. It's true that they were still owned by the owner of the manor. So somehow it's true that it's kind of has a bad implication. However, we can look at the good part of it. The good part is that there is a piece of land that was used by many people commonly, the commoners, they were called. Next slide. And so what should be such material commons? Probably much more than me. But what I put in this slide is that what I think it should be. A digital place, I actually imagine it such as something like Amazon looking like. You go, you can look in books, you can book in other things like electronics, appliances, and so on. And so you could do with these different marketplaces in different areas of materials development. And then you can buy a service which could be free if it's data coming from a university or RTOs. It could be maybe for a fee if it's proprietary data. But of course, it has to be a trusted system where all stakeholders have a place. As I said, data ownership should be respected. User activity probably should be recorded to avoid misuse of data, with some boundary condition, therefore. Next slide, and last slide, importantly. So I think I'm here to engage with you and to tell you that I think you should engage with each other. I think you're doing it, but I don't know if any of the project of the slide were missing from today's workshop. Probably we should involve them. Because you are the right people to define the scope, the content, the rules, the safeguards that we need, the gaps, the needs, so the governance, as you mentioned. And with this, I thank you.
Thank you very much, Andrea. So we started late, but we arrive on time at the end of this session. So thanks to all the speakers for keeping the time. So we have time for one or two questions if we take 5 minutes for the break. So is any question here or from the online participants? You see any raised hand or written? So maybe I will start with one question. So, in my understanding, so ontology is about commons, and also if you take the Earth, where we extract all these materials, is a common for all of us, and also the world with the batteries, with cars, etc., is also a global, let's say, collaborative business. So we need, so you know that maybe your iPhones are produced in China with the conditions by Foxconn, that the conditions you know, but many hundreds of components, they're arriving there from other places and so on and so forth. So ontologies, they have to support things that are designed and produced everywhere. So ontologies must be also global and globally adopted as commons and as standards. So Andrea said that we have the initiative in Europe, so we have the Japanese, we have the Americans, so we have to work with the Chinese. We will have to work again with Russians after all this story is finished, because the war will finish sometime. So how to take care of that? So the globality, the global dimension of working on ontologies, and how to assure that we speak the common language. We have a common vocabulary where the global players. So this is my question to. This have various dimensions, technical, technological dimensions. So I know that in OntoCommons will work well with the Industrial Ontologies Foundry, but there are many Americans, there are some Chinese, there is almost no Japanese or no Indian. So Indian is also a big factory, etc. So we have to take care of that as well. So Andrea, you have any hint about that? I know that the European Commission has projects for international collaboration, but more particularly on the ontology and commons part, if you have some hints. Yes, thank you.
Well, I think we keep having an open approach to research and innovation, especially at research and innovation level, which is a bit different than market ready products. So collaborations with all actors from all the world is welcomed, especially if this fosters a better innovation ecosystem, because of course standardized ontologies, standardized harmonized data is a key also for market developments, for trade, for exchange. You can see USB-C how it's revolutionizing our devices. So it's we should keep it open as much as possible.
Very good. Also from the technical point of view, so we know that we're try to work with standardization organizations. So Hedi said some example. IWF is another example. So we have also efforts. So ICF now is you have a common understanding or MOU with OAGI. So in terms of in this field, in promotion of ontologies as global standards. And from my perspective, so knowing that the ontology development is just OOL, the first step is talking together and agree on a common vocabulary. So you talked about unlocking the value of data, data sharing. Data sharing is built on trust. And when we talk together to agree on a common vocabulary, we develop trust even without knowing it. And if we work at the global level, developing common ontologies, this will help also to develop more trust in the world and maybe have less war, probably, I don't know, starting with manufacturing, which is a source of wealth. You wanted to say something, Michele?
I noticed there were a couple of questions that came into chat.
Okay.
I don't know if someone can pick them up, maybe?
Yann, you can.
I can pick them up, so just a second. Yes. The first one is actually related to the topic that we just discussed. Okay. To what degree do we include actors from global markets outside of the EU, Asia, US, etc.? So this is what we discussed. And the second one is, where do emerging bio-based materials fit in the material story?
Gerhard?
Well, I mean, I can certainly just talk about, well, maybe I would just like to make one remark regarding the common language. So, I mean, this will also be discussed again in the next session, but still, I think the OntoCommons ecosystem is a very good approach. I mean, and in particular that we highlight here the plurality as well, plurality of perspectives and also of different top-level ontologies being, you know, I think we cannot be too prescriptive. In the end, we have to leave a certain degree of openness. The other aspect in terms of international collaboration is that I was at the Research Data Alliance plenary in Gothenburg a couple of weeks ago, and I think this is and remains a very strong forum, and we've seen a very strong participation, which was really great. I mean, more than 500 people coming together physically, plus more hundreds online, and so the topics ranging from, you know, for example, fair data sharing with bringing that together with IP, to ontologies and harmonization. We had a session, a very well attended session with people from Japan, from Korea, from Australia, and so on, from the US, and of course many from Europe, about domain ontology harmonization in materials. So it's clear that the desire to work together is there, right? But it's also clear, you know, that there are today different approaches. But this is the forum why we need organizations also like RDN, a global level, to get together to overcome and discuss how we get together. And we're planning there actually a new working group on harmonization of domain ontologies for materials, which is really a global group, right? So this is, I think, what we need to pursue.
Thank you. Another question?
Dimitris, just add to the where does it actually fit the bio-based materials? You know, for instance, if we look at Andrea's schema that he showed about regenerative economy, I mean, there is some entropy, of course. You can't avoid it, and it's indicated in that cycle. So novel bio-based materials actually balance out the entropy that's caused by the loss of some of the resources that we have to dispose of. So they are hugely encouraged, and if anything, they contribute to the ultimate sort of positive result. You know, the ambition is to create a positive impact on the environment rather than extractive. So bio-based materials are obviously high priority, and we are now designing a NEB Academy that has got bio-based materials at the core. It is a proper it's an initiative that's being rolled out very, very fast. Actually, it's pulled together actors from the Nordic countries. The Nordic governments have put forward funds for this, and also some excellent centers that are founded together with Fraunhofer in Slovenia. So there's an excellent center for example, for analysis of wood and bio-based materials that is actually Fraunhofer co-owned, and it's going to be the first hub for the NEB Academy. So it would be very nice to link it to the activities of the Materials Manufacturing Commons.
Very good. Yes, Andrea.
I don't know if as a panelist, I am allowed to make a question.
Please.
I would like to ask Hedi about the OCHES system. You said that you are working with international standard setting organizations and towards ISO. Maybe I missed a little bit the point. What are we adding at? Maybe it also replies to the question on the global collaboration.
Yeah, so let's say the first...
Hedi, talk to a micro.
Yes, so the most near organization that we are working with is OAGI, that is hosting Industrial Ontologies Foundry. So there is strong collaboration at this level. And also in terms of works regarding the oil and gas industry, it's more focused on the part 14 of the ISO 15926. So it includes parts from maintenance and other stuff regarding systems. So we collaborate in this term. So with people from Australia, from US, and with a strong collaboration with industrials also. I can cite Total Energies from France, for example, and other Norway oil and gas industrial partners. So there is a strong link regarding this, and this move is really to enforce this by sharing what you are doing in OntoCommons and to adopt this rigorous methodology and tools. We are sharing tools with them. We are sharing principles. So it's really a strong collaboration between IUF, PCA, and OntoCommons at this level.
Okay. So I think we have to go to the
Norway organization. I don't know. Yeah. Yeah.
Yeah. So I think now we made the break, and thank you very much. Also the present.